Hi everyone, welcome to this new section. And in this section, we are going to talk about the network optimization, like how we can achieve better DPS in a fabric network. And in this particular lecture, we are going to see what are the factors that influence the performance of a network. So if we head back to the screen here, we can see that I have listed some of the areas which impacts the network DPS. So the first section is the network configuration. And in this particular section, I have mentioned some points which directly impacts the TPS of a given network. So the first section is, or the first area is the channel configuration. And in channel configuration, we have something called as block size and the block frequency and the endorsement policies. Now, these three parameters directly influence the channel or the TPS, because we know that in Fabric, transaction is stored within a block, and the block size determines that how many transactions can be kept in a block. Then we have something called as block frequency, or this is also called as a block timeout as well in the channel configuration. And this determines that at what interval a block should be created in a Fabric network. So lower the value, which means that the block will get created as soon, right? So if we keep the value of, let's say, block frequency as 2 seconds, then it means that the block will get created immediately after 2 seconds or every 2 seconds. Now, third parameter is the endorsement policy. And here we are talking about the chain code endorsement policy, which defines that which all orgs has to get do the endorsement for a given transaction. Now, if we have an endorsement policy, that means that all the organizations that are the part of that policy, they all have to endorse the transaction before that transaction get actually committed. But if we have a loose endorsement policy, something like a or endorsement policy, in that case, only either of the organization from that policy can just simply endorse the transaction, and the transaction can be marked as validated. The next level of the configuration is around the order, where we have number of orders, the type of ordering consensus we are using, the resources that we have given to the ordering node. So all these determines that what should be the TPS. And also to note that if you just have more number of order, doesn't always mean that you will have a higher TPS, because the transaction has to also get propagated to the majority of the orders. So let's say you are running a network of, let's say, 10 orders. So in that, the transaction has to be validated by majority of the order. In this case, this is 6 orders, because the majority is going to be 6 orders for our ordering nodes of 10. The other configuration that we have to keep in mind is the peer configuration, which also is around the number of peers, the peer resource in the state database. Now, the number of peers always doesn't mean that you will get a higher TPS, similar to what we saw in the order part. Then also the peer resources and the state database. Now, in Fabric provides us two kind of a state database that we can use. First is the level DB, and second one is the CouchDB. Now, level DB is built into peer database or into the peer nodes. But if you are using Couch database as an external database, then you will have to set up that Couch database additionally, so that all the state records are stored into that state database, which is the CouchDB. And CouchDB also impacts somehow into your performance part, because when you do read operations, those read operations are kind of read from the state database. And if you perform any operations like the history operation, like where you want to get the history of a record, then in that case, that record is directly coming from the level DB or from the actual transaction log. But when you do read operation, then in that the query has to be sent to the CouchDB. And in that case, you have to optimize the CouchDB indexes as well. So if you're using state database, then you have to ensure that your CouchDB is optimized and you have done the proper indexing for the CouchDB. Now, the other area is the second area is the application logic part. And here I'm specifically talking about your code part, basically the client application that you are writing or that you have written to send the transaction, that should also be optimized. And additionally, your smart contract should also be optimized. You have to also always ensure that your smart contract is not that complex, because if your smart contract is complex, then it will always add to the latency, which in turn will add up to your TPS. The other area is the network environment part. And here I'm specifically mentioning about the network latency and the bandwidth. So if all these resources are deployed across multiple region or different region. So let's say your peer node are deployed in maybe West US region, and your ordering nodes are, let's say, deployed in some central India region, right? So if they are in different region, then they'll always add up the latency, because it's a network call that these components are making up, and since they're in a different region and geographically they are very far apart, then that will always add up to a latency. Now, some external factors like the load, how much load you are sending up to your network, the hardware, the type of the hardware that you are using, and hardware, I'm talking about the type of machines that you are using to run these nodes, and then the software versions as well. So this was it for this lecture, and in the next lecture we are going to optimize the running Fabric network, and we'll run the benchmarks as well before optimization and after optimization, just to see whether the changes that we are making, are they really helping us to achieve the higher TPS or not. So this was it for this lecture, and I'll see you in the next one.